This week we're going to be talking about some of the mathematics behind finance, which means primarily we're going to be talking about interest. So we'll start today with section 3.1 on simple interest. And the first concept of interest is, of course, when money is borrowed. So either you're borrowing money from a lender or you've deposited money in an account somewhere and that institution is effectively borrowing money from you. When money is borrowed, a fee is charged to borrow that money, right? And this fee is, of course, called interest. So our first concept today, and really everything behind this whole section, is the simple interest formula, and it's a fairly simple formula. I is equal to PRT. So I is P times R times T, and I is the interest that you're paid, or interest that's due. P is the principal, the amount of money that's borrowed, the amount of money you start with. R is the interest rate, the annual interest rate, usually given annually. And this is, of course, when you're working with it in this formula, you're using it as a decimal, right? So you're going to put it as a decimal. So you have to convert if you say have a 10% interest rate. 10% is you divide by 100, so that's 0.1. And time, T is time in this formula. Time is given in years. So if you're working with other units, you have to convert them to years. So we take 360 days to be 1 year, 52 weeks to be 1 year, 12 months in a year, and 4 quarters. And sometimes you'll see the word semi-annually. That just means half of a year. But this is it. This is effectively everything in this whole section is this formula right here, I is equal to PRT. We'll modify this in a second to talk about total amounts or future values, but this is the simple interest formula. And we'll do a few examples with this. So here's our first example, just using this formula right off the bat. Find the simple interest if P, our principal, is $300, our annual interest rate, R, is 7%, and the total time period is 2 years. Well, we just plug straight into our formula. I is equal to PRT. So we'll plug in. Our interest is going to be, P is 300, times R, the interest rate. Remember, I have to convert this to decimal. So 7%, just divide by 100, that's 0.07. And our time period, T, is 2 years. So remember, this always has to be in years, but it's already in years, so it's just 2. And then you plug this into your calculator, and you'll get $42. Does it seem reasonable? Yeah, always check. Make sure your answer seems reasonable. Obviously, if I have like $1 million here or something, that's not reasonable at all. So just, yeah, that looks like a reasonable interest rate. So you'll see lots of problems like this for homework using this formula. And I want to note that we were able to solve for I here because we were given 3 of the other values. Quite often, though, the question won't be solved for I. It'll be given any 3 of these four values, find the 4th one. So let's do another one. So in this case, we're given, again, as always, 3 of the four values. We're given our interest is $60, our principal is $2,400, the interest rate is 5%. The question is find T, right? So I is, once again, our simple interest formula is PRT. So I want to solve for T. I'm asked to find T, so let's figure out what T would be. If I'm isolating T, I just need to divide both sides by PR, right? So T is going to be I over PR. And now we just have to plug these things in. So my interest rate is 60. Or not my interest rate, but my total interest is 60. Our principal is $2,400. And R, the annual rate, is 5%. So once again, converting that to decimal is 0.05. And you'll plug this into a calculator. Actually, this one we could probably do in our head. 2,400 times 0.05, that's actually 2,400 times 1 over 20. 2,400 divided by 20 is 120. This is 60 over 120, which is just 1/2. 1/2 or 0.5. What's the units? Well, remember T is always given in years, so this is 0.5 years. Or if you want to convert to some other units, maybe something like 6 months, right? Half of a year is, of course, 6 months. I think we'll do one more. So once again, a very standard type of question. We're given 3 of the values, find the 4th one. So just to really commit this to memory, I is PRT. I like to start off with the formula every time I do these problems. I is PRT. We're given IPT. The question is to find R. So we'll isolate R. We'll solve for R. R is divide both sides by P and T. R is I over PT. And that means, so we'll just plug in our values. We've got I is 48. P is 600. And T, well, remember we always have to convert this to years. So, so we have to convert this to years. 240 days, there's 360 days in a year, so that's 240 over 360. And now you just plug this into a calculator. Be careful to make sure you've sort of got brackets around everything so that everything distributes properly. But you plug this into a calculator, and you'll find that this is 0.12. Well, remember, that's the decimal form. If you want it as a percentage, you multiply by 100, right? So R, our interest rate, annual rate is 12%. So be careful with this. Anytime you're working with time, remember you've got to convert to years. So 240 days, you would divide by, there's 360 days in a year. If you're given 8 months, you divide 8 by 12, and so on. But let's talk about the total amount. Let's talk about the future amount if you're calculating interest as well. So this is what I was saying. Instead of thinking about just the interest, let's think about sort of the future value of the money. So after T years total, the amount that the borrower owes to the lender will of course not just be the interest that they're being paid, but the original principal plus the interest. So here's a very simple formula for that, right? The A usually for amount, but the way you should think about this is as future value. It's just P plus I, the original principal plus the interest paid. And if you want to plug in the simple interest formula here, this becomes P plus I, which is PRT. And quite often you'll see this factored, so factor out the P. This is P times 1 plus RT. So A, I suppose we can leave the arrow there, but it's also that A. A is P times 1 plus RT, where you can think of A as being the future value and P being the original amount you invest. This is of course still the principal, P for principal, but you could also think of this, I can't get a nice R there, principal, you could think of this as being the present value. So this is a formula that relates sort of the present value of your money, given the future time and the annual rates, it outputs the future value of the principal. So let's do an example using this. So once again, this is just like the problems we just had. That formula, A equals P times 1 plus RT, is a formula involving four unknowns. And you'll see a lot of these problems for homework where you're given 3 of them and you have to solve for the 4th value. So in this case, we're asked to find A, and A is P times 1 plus RT. Well, we'll plug in the numbers. So A is going to be, P is, our principal is 4,500, times 1 plus R, the interest rate. 10% in decimal is 0.1. And our time, we have 1 quarter here. So how many years is that? Well, there's 4 quarters in a year, so this is 1 quarter over 4 quarters. And there's our computation. So we plugged in all the numbers, now you just plug this into a calculator, and the output is going to be 46.12 and 50 cents. So we're not doing anything very different than we did with the simple interest calculations. We're just adding the principal back in too, right? So the actual interest, if you subtract off 4,500, the actual interest was $112.50. So we're just taking the interest plus the principal to output this number, 4612.5. So we'll do one more of these before I start to sort of making these more wordy problems so they feel more like applications, but I want to sort of make sure we're used to working with these formulas. So once again, 4 unknowns, we're given 3 of them, and the question is to find the 4th. The formula, I'll just write down the formula for starters. A is P times 1 plus RT. Here we're given everything except for P. We're asked to find P. So let's isolate P before we do anything, before we start plugging things in. So P is going to be, well, we'll divide both sides by 1 plus RT, right? So P is A over 1 plus RT. And now we're given all 3 of these values, so let's just plug them in. Our future value is 910. Our annual rate, 16% in decimal, divide by 100, so that's 0.16. And T, the time in years, there's 52 weeks in a year, so T is going to be 13 weeks over 52 weeks. And you'll just plug this into a calculator, again, being careful to make sure sort of everything ends up in the right spot. You have brackets around the right things. You do 910 over all of this in brackets. And this works out to 875. Again, always ask yourself, is my answer reasonable? Well, you'd certainly expect it to be something less. The original principal should be something less than the amount that's paid out, the future value. So indeed that's less. And this just means my interest, by the way, if you want to compute the interest is the difference between A and P. So the interest that was actually paid here would have been $35. So let's do 2 more examples, but we'll add some words to these problems to make them feel more like real world applications. All right, so the first of our last 2 examples is the following. A loan of $7,260 was repaid at the end of 8 months. The question is, what size repayment check was written if an 8% annual interest rate was charged? So what are we given? We're given the annual interest rate. We have R. R is 8%. We have the time, T. The money was borrowed for 8 months. And of course, there's 12 months in a year, so that's 8 over 12 years. And we're given the original principal. The original loan was $7,260. So we're given P is $7,260. So what's the question asking for? The question is asking for what was the future value? What was the amount that was repaid after 8 months? So this is what it's asking for. It's asking for what is A. Well, now we're down to the problems we just did, where we just have to plug these things in, right? We have our formula. A is P times 1 plus RT. So we'll just plug in these 3 values. So the amount repaid would have been the principal, 7,260 times 1 plus our interest rate, 8% in decimal is 0.08. And the time period, 8 months in years, there's 12 months in a year, so 8 over 12. And that's all it's asking us to compute. We should, before I even plug these numbers into a calculator, we should of course get something a bit larger than 7,260. And if you plug these into a calculator, you get 7,647 and 20 cents. a reasonable looking number, right? And if you wanted to ask what the actual interest paid was, well, you could use the formula. You could use I equals PRT and just plug these values into that, or you could take the difference, right? You could take the difference between A and P to get I, which looks like it's just short of $400. Just a little bit short. All right, so we'll do one more that's quite a bit more interesting than this problem. So here's an interesting question. This guy George finds a company that charges the following rates. They charge 59 cents per day on every $1,000 that you borrow. So George looks at these rates, he decides that's acceptable, so he decides he's going to borrow $3,000 for 60 days. The question is, what amount will he repay, and what annual interest rate is he paying? So what's he going to repay? Well, let's figure out what the actual interest here is. He's paying. What is he paying? He borrows $3,000, so he's paying 59 cents per day. So 59 cents is $0.59. How long does he borrow it for? He borrows it for 60 days. So 59 cents per day for 60 days total. And that's per $1,000, but he borrows $3,000, right? So we need to triple this. All right, so 59 cents per day times 60 days total, and then that's per $1,000. Since he borrows $3,000, we multiply by 3. The interest in this case, I plug this into a calculator. I have 106. Is this right? Yes, $106 and 2 cents, or not 2 cents, and 20 cents, 106.2. All right, so once again, just to recap, right, the rate they're charging 59 cents per day, so 59 cents per 60 days, because he borrows for 60 days total, and that's per $1,000 borrowed. He borrows $3,000, so we triple it. And this works out to, over the 60 days, he pays $106.20. So what amount will he repay? Well, the amount that he repays, A, is just the original principal, $3,000, plus the interest that he paid, I. So this would be 3,000 plus 106.2, so let me stop skipping steps. 3,000 plus 106.2, which is $3,106.20. So there's the first part of the question. That's the amount he repays. The more interesting question is, what's the actual annual interest rate that he's paying? So this interest is given this fee that they charge is given in a strange way. Let's compute this to the effective annual interest rate here and figure out what this actually is. So we know our simple interest formula is I is PRT. I know everything except R. The question here is to solve for R, right? So this means R is I over PT. So R is going to be, we've already worked out the interest. He's paying 106.2, so this is 106.2 over the principal, the amount he borrows. He borrows $3,000. And the time in years, he borrows for 60 days, 360 days in a year, so the time in years is 60 over 360. A nice number, that's just 1/6. And you plug this into a calculator, and you find that R comes out to, I've rounded here to 4 decimals, 0.2124. So there's the decimal form. If I put this in percentage form, multiply by 100, that means that the interest rate he's paying is 21 0.24% per year. A really quite high interest rate. So this whole deal of 59 cents per day on each $1,000 is quite a significant interest rate. So an interesting problem where we didn't rely just on formulas. We had to sort of take the problem as it was and figure out what the actual interest was that he's paying, and from there plug that into our simple interest formula to convert the rate to a standard annual rate. Next up we have compound interest, where interest really starts to get interesting, but this is the end of this section.